Hi there, I'm Dr. Chris, and in this video I'm going to talk about the key elements of basic petroleum geology. In a previous video I covered the 5 features of geology which are needed for petroleum to be found. As this video is part of a Flipping the Geophysics Classroom series, I'd like you to think about geophysical techniques and geological timing as you watch. Here we go.
To start, we look back at the 5 basic geological features required for hydrocarbons to be found. These include a source rock, a migration path, a reservoir rock, a cap rock or seal, and a trapping mechanism. Let's go into some more detail. The source rock or kitchen is where the hydrocarbons are cooked. We want to know the rock type itself, perhaps a shale or a limestone, the rock volume, so we can estimate how much hydrocarbons may have been generated, the conditions of deposition, whether or not the organic material was preserved in an airless environment by being buried rapidly, the depth of burial, to understand the temperature at which the hydrocarbons were cooked and the time they were deposited, and the original organic content.
A question we need to ask ourselves is which geophysical techniques are best used to identify these elements. We can use seismic methods, ground penetrating radar, gravity, magnetics, electrical resistivity, borehole logging, radiometric surveys, and the list goes on. Have a think about it.
Most of these elements of the source rock can be identified using geophysical methods, all but one. Next is the migration path, which is necessary for hydrocarbons to move from the source rock to the reservoir. We'd like to know again the rock type, in this case a silty rock, the orientation path, which can help us know where hydrocarbons will accumulate. We want to know if the rock is fractured, which can be both a positive and a negative for a migration path. Finally, we also want to know past and current permeability of the rock. Again, most of these elements can be identified using geophysical techniques, except for one. Next, the reservoir rock. Again, we are interested in rock type, perhaps a carbonate or a sandstone. We want to know the rock volume, also the conditions of deposition, the current and original porosity, which is dependent on grain characteristics as well as depositional conditions. Is there faulting or fracturing? And finally, we want to know permeability, which is not uniform. Again, geophysical methods can identify all but one of these elements. Next, the cap rock. More generally, we can call this a seal, which can go hand in hand with traps and trapping mechanisms covered next. We are once again interested in rock type, which should be impermeable, such as a salt, shale, or limestone, possibly associated with a facies change. The volume of rock is important. We also need to know if the rock is being faulted and sealed, and whether the rock is fractured or unfractured. We are also interested if unconformities cut through the section. Again, have a think about which geophysical techniques can identify these elements. And this brings us to
Traps and trapping mechanisms. Now the interpretation of these is quite an art form and can be extensive, so I'm only going to cover a few of the possible combinations right now.
traps and trapping mechanisms can be structural, stratigraphic, or a combination of the two. Structural traps occur when the earth is deformed in some fashion, including folding and faulting. Stratigraphic traps are more depositional in nature. In this familiar case, we have 2 structural anticline traps with oil and gas in the reservoir. If an unconformity cuts through the anticlines, we now have a single structural anticline trap on the right and a stratigraphical trap under the unconformity if the rock above the unconformity is impermeable. If, however, the rock is permeable, no hydrocarbons will accumulate. Here the layering is tilted. If the timing is not advantageous, hydrocarbons of the source rock will flow up and away. However, if an unconformity cuts through the layers, again with an impermeable rock above the unconformity, hydrocarbons can accumulate in this stratigraphic trap. In this case, a reef is formed on an ancient seabed, then covered with an impermeable shale. There is a high likelihood of hydrocarbons being trapped within the porous reef. In this case, water flow has carved out a channel, filled it in with sand, covered with shale, and buried over time. The reservoir rock, being sandstone, will hold hydrocarbons, and the impermeable shale will cap the reservoir, resulting in a stratigraphic trap. In this case, a sandbar at the edge of a retreating and advancing ancient sea, when buried by shale, will become a good stratigraphic trap. Here, a pinch-out trap is formed when deposits have thinned out over time, creating another stratigraphic trap. And of course, there are multiple combinations, where tilting, folding, and faulting all play a role in creating structural and stratigraphic traps for hydrocarbon accumulation. But for now, I will leave traps and trapping mechanisms here.
Let's look back. There are a couple consistent elements across each of the 5 features necessary for hydrocarbons to be found. These include rock type, rock volume, porosity, permeability, fracturing, faulting, and rock orientation. Have a think about which geophysical techniques might best identify these elements and how depositional conditions and timing affect each of these elements. If you liked my video, please give me a big thumbs up and subscribe to my channel. Till next time, I'm Dr. Chris, and keep rocking.